Okay, we are going to review probability, and we're going to do it while reviewing formulas for area. This is called geometric probability. Remember, to find probability, you put the number of successes over the number of possible in the entire event. So when we do geometric probability, you're going to see we're going to have pictures, and we're going to put the area of the region of the event, and we're going to divide that by the entire area. So to get us to answer one of these questions, we're going to first, in this picture right here, we're going to find the area of the circle. So in order to find the area of the circle, we need to know the formula for the area of the circle. So I am going to say right now, it has been a very long time since I've studied the area of a circle, and I don't remember that formula. So I just want to show you guys, you have this amazing resource. Google. You can just type in area of a, and it's even coming up, area of a circle, and it tells you the formula right there. So if there is something that you come across on this assignment and you don't remember how to find the area of it, please just look up the equation formula. So pi r squared is the area of a circle formula. I don't know if my pen is saying. So circle is pi r squared. So in this picture, we need to know the radius. Well, what I do know is a side length is 6. So if I go from P straight up, and this circle touches both sides of the quadrilateral, and then this is the center of the circle, it has to be 3 and 3 to equal 6. So this is just telling me that no matter where I go in this circle, the radius is 3 centimeters. And then to find the area of the circle, we do pi multiplied by r squared, so we do pi times 3 squared, which is 9 pi. Find the area of the square, area for, would be centimeters squared. Okay, find the area of the square. So it does tell me that this is a square. So if we have this side as 6 centimeters, then this side would also be 6 centimeters. To find the area of the square, you do side squared. So we do 6 squared. So 36 centimeters squared. So here's our geometric probability part. If we take a dart and we throw it randomly and it hits anywhere on this picture, what would be the probability that the dart will hit the circle? So let's see. To hit the circle would be, out of all of this square, how much area is the circle? So we know that the area of the square is going to be the total amount. That outside area is going to be that bottom number when we do probability that it hits the circle. Okay, the bottom number, the area of the entire region, is going to be the square. I'm writing in words now, and then I'm going to go ahead and put the numbers in just a moment. So we've got the area of the square, and then on top, we want the area that we want it to hit, which is the circle. So the area of the circle. So since we know both of those amounts, the area of the circle is 9 pi centimeters squared, and then the area of the square is 36 centimeters squared. This should tell us the probability. Centimeters squared is going to cancel. If you want, the 9 over 36 could cancel as well, but really you can just use your calculator at this point and type it in. So I'm going to take 9 pi and I'm going to divide that by 36. and we get that it is 0.785. Well, this entire worksheet that you're going to have today, we're going to round to the nearest hundredth, which is the second decimal place. So to round, we have to look at the 5, and that tells us to round the 8 up to the 9. That does not affect the 7 whatsoever because it just turns to a 9. So we should have that it is approximately 0.79. So that is the probability. And if you wanted to turn that into a percent, which you do not need to do that for this assignment, but just talking about it, that would be 78% of the time it would hit the circle. 79%, sorry, of the time it would hit the circle, or 78.5%. Now, not included in this first page of questions, what if the question was, what's the probability that it will hit the shaded region, which is not the circle? So I'm going to add in another question here. The probability that it doesn't hit the circle, or you could say probability that it hits the shaded region. Well, on top, instead of doing the area of the circle, on the top we're going to do the area of the square subtract the area of that circle. And we still divide it by the area of the square. So the area of the square was 36, and we subtract the area of the circle, 9 pi, and we divide that by 36. Remember, if you have these new calculators, if you hit alpha y equals, you get the, and then enter, you get a fraction. Makes it a little bit easier to type things in correctly. 36 minus 9 pi over 36. And that equals 0.21. We look at the 4, it says don't round it. So 0.21, 0.21. One more thing about probability that you definitely need to take notice is if I added hitting the circle with not hitting the circle, that would be basically hitting anything. And that should equal 1, which is 100% of the whole figure. Okay. Second one. The following diagram, math, M-A-T-H, is a rectangle with an inscribed circle, which means it's touching the sides. The circle has a diameter of 8 centimeters. So that whole thing is 8. And the rectangle has a height of 12 centimeters as shown. Find the probability that the dart thrown randomly will hit the circle. So I need to take this circle and we need to find the area of it. It does say that 8 centimeters is the diameter. That means that each of these is 4. And what that tells me is the radius is 4. So the area of the circle is going to be pi r squared, which is pi times 4 squared, which is 16 pi. The area of the rectangle M-A-T-H, math, so creative. Let's see, it has a height of 12 centimeters. So this is 12, but what's this? Well, that's the diameter of the circle, 8. So our area of the rectangle, 12 times 8, which is 108, I think. No, 90, I don't know what it is. 96. And we want to know the area that, or sorry, the probability that the dart would actually hit the circle. So we're going to do the area of the circle. So this is, I'm sorry, probability hit the circle. It's going to be the area of the circle divided by the area of the rectangle. It's the part that we want to hit divided by the full area of everything. So we'll have 16 pi divided by 96. Use my calculator. And I get about 0.52, and that 3 tells me do not change any of the numbers, 0.52. 0.52. In your assignment, I'm going to ask you to put that 0 in front of the answers because you have to type it in. It has to match the numbers that I've typed in. So make sure you put the 0 point in front of any of your answers in the assignment. This also does say, give your answer as a fraction, a decimal, and a percent. And I'm not really going to take time to do every single little thing that it says on this worksheet because the only thing I'm asking you to do in your assignment is the decimal. So we're just going to ignore the rest of it for this lesson. In the following diagram, right triangle ABC is inscribed in a circle. That means the A, the B, and the C are all touching the circle. It is given that AC is 26. I'll go ahead and mark some of these things as I'm reading it. AC is 26, BC is 24, and AB is 10. That must be a triple. That's a 5, 12, 13 triple. It also says that AC is the diameter of the circle. So find the probability that a dart thrown randomly will hit the triangle. Give your answer as a fraction, a decimal, and percent. We're not going to do all of that. We're just going to do the decimal for this one. So I need to know the area of the triangle, and we need to know the area of the circle. So for the triangle, we have to do 1/2 base times height. And the height and the base have to connect with a 90-degree angle. So I can draw in this height and attempt to find it, or I can turn my paper and say, well, this is going to be the height and this is going to be the base. If I have two angles that make 90 degrees, I'm going to use those as the height and the base, because it doesn't matter if I turn my picture, the area of the triangle stays the same. So we're going to do 1/2, 24, and 10. Oops. So that would be 120. I don't know what the units are for this one. Okay, and then the area of the circle, I need pi r squared, and we look here, and our diameter is 26, so that means that the radius is 13. So we're going to do pi times 13 squared, or 169 pi. Now the chances that we'll hit the triangle, so we're going to put the area of the triangle, and divide that by the area of the circle. So the area of the triangle, we have 120. The area of the circle, 196 pi. And we're going to type that in our calculator. When we type this in the calculator, we have to be careful. I see all kinds of students make mistakes by typing this in, and I'm going to show you. I'm going to show you what happens. Okay, so first of all, I'll type it in correctly. And I'm going to do it using a fraction to start, but not everybody has the fraction button, and some people forget about it. So this will definitely give us the correct answer. It's about 22.6%, 0.23. Now what happens is when you divide 120 divided by 169 pi this way, it's not going to give you the same answer. And the reason is your calculator does order of operations, and it does 120 divided by 169, then it finds that answer and it multiplies it by pi. So if you want to type it in this way, you need to do 120 divided by parenthesis 169 pi, or you need to do 120 divided by 169 divided by pi. So that both 169 and both pi, they're both dividing the 120. So you can see all those three give you the same answer where this one did not. So just be very careful. Again, it has to be less than 1 if it's a probability. So that should tell you right there, I can't be right on that one. So 0.23. Uh-oh. Okay. So here we have a dartboard, and the dartboard is a bunch of concentric circles, which they all share the same center. That's what concentric means. Co, and then center, same center. And it tells you the radius of each circle. So we're going to find the area of circle A. The radius of circle A is 2 inches. So the area of A is going to be pi multiplied by 2 squared, 4 pi. Now the second says find the area of circle B that is not covered by circle A. So the area of circle B, but not covered by circle A. So circle B has a radius of 4. That includes circle A. So what we need to do is we need to do the area of B, and then we need to subtract off the area of A. The area of B and subtract off the area of A. So the area of B is going to be, let's see, the radius is 4. So pi times 4 squared, or 16 pi. And then we have to subtract off the area of A, which we just found, 4 pi. If you have 16 pi's and you take away 4 pi's, you get 12 pi. Now you can also use your calculator. Find the area circle C that is not covered by circle A or circle B. So for circle C, we need to subtract off circle B. We do not have to also subtract off circle A because circle A is contained in circle B. So really we just need C and then take away the area from B. It's like we're cutting out all of circle B. So area of C minus area of B. See, circle C is 6 centimeters for the radius, or inches for the radius. So we're going to have pi times 6 squared, which is 36 pi. Subtract, and then we already know area of B is 16 pi. So 36 pi, take away 16 pi's, we're left with 20 pi. And then find the area of the dartboard that is not covered by circles A, B, or C. So basically we're taking D and we're going to cut out C, which automatically cuts out B and A already. So we just need to take circle D, the area of circle D, and subtract off C. So D is 10 inches. Pi times 10 squared, which is 100 pi. Subtract. And then C is 36 pi. And we are left with 64 pi. Okay, now we're going to have the exact same picture, but this time it is on a rectangular piece of corkboard that is 2 feet by 30 inches. And right now, I notice something that doesn't sound right, because 2 times 30, that doesn't look right to me. So pay attention to units. This is 2 feet, this is 30 inches. There's no way that we can calculate things when they're in different units. So I'm going to turn everything to inches, since all of this was in inches. I'm going to turn everything into inches, and this is going to be the same as 24 inches. So we're going to get rid of that 2 feet, and we're going to make it 24 inches instead. So we want to find the probability of an event, assuming that the dart always lands on the corkboard. So if the dart's going to land somewhere on here, what is the probability that it lands on circle B or circle C? So we need to know the probability of this part out of the entire dartboard. So the entire dartboard area is going to be the rectangle, which is 24 times 30. which is 720. So we're going to take the area of C, because that's the part, nope, it's C or B. So what I need to do is I need to think about C or B, which does not include D and it does not include A. I don't have to worry about D at all. I just need to take C and I need to subtract out, I need to like cut out with my scissors, cut out A. C subtract A, that's what I need to do on top. So we're going to do the area of C subtract the area of A, and then I'm going to divide that by 720. So the area of C, we found all this information already. 36 pi. Subtract off the area A, which was 4 pi, divided by 720. So that's going to be 32 pi divided by 720. And I'm going to go ahead and use my calculator now. Oops, 32 pi divided by 720, and that's about 13.9, but then the 9 tells me to round the 13 to 14, so 0.14 would be the probability of that event. A random dart lands just on circle B, so we're talking about just the ring of B, not A, not C, not D, just B. So we're going to go up here where the area of B that is not covered by A. So we already know that answer. That's 12 inches, or sorry, 12 pi inches squared. So we're going to take that, 12 pi, and we're going to divide it by the total area, 720. And that's what we're going to type in. And it is 0.05. So that would be, if I was talking percent-wise, it'd be like 5% chance. And then a random dart will make a bullseye. So a bullseye would be circle A. And we need to just find the area of A over the whole area. So let's see, the area of A we found in question 4, so that's 4 pi over the total area, which is 720. I feel like it's going to be a really tiny number. And it is. So I'm going to take that 7, I'm going to round the 1 up to 2. So 0.02, which is just 2% chance that if it was random, that it would hit the bullseye. Okay, so your assignment is going to be similar to this. In your assignment, though, I've made it very easy. Every single time in your assignment, you're going to be finding the shaded portion every single time in your assignment. I made the directions the same for every single question. There's just different pictures. And you're going to complete that on Cami or on paper, and then you're going to submit your answers on Canvas. To submit your answers, I've had some people asking me about this. Submit answers, you're going to go to the assignments link. Now, if you have any questions at all, remember my office hours are 12:45 to 1:45, or just send me an email and I can answer you. All right, have a great day.